Okay, Assalamualaikum and good morning, everyone. Alright, so this is the continuation of periodic table that I lost the video earlier. Alright, so it's for question number 6 until question number 10. Okay, alright, so for question number 6, periodic table, going down the group in the periodic table, so it can say that electronegativity decreases. Okay, right. So we have this three statement di sini. Electronegativity berkurangan. Okay, and then the metric properties increase. Okay, metric properties increase, and then the ease of cation formation increases. Okay, so electronegativity decreases. Okay, so this is true because bila kita turun going down the group, okay, the size become bigger. Okay, jadi bila size bigger, it makes the electron lebih susah untuk ditarik. Okay, bila dia semakin besar, dia lebih mudah untuk apa? Release electron. Jadi electronegativity adalah untuk tendency to attract electron, untuk menarik elektron. So dia kata di sini electronegativity decreases. So this is correct. Okay. The metallic properties increase. Yes. Okay. So metallic properties adalah kesenangan untuk dia menjadi metallic bond, to form a metallic bond. So macam mana metallic bond? Because if the size is bigger, it's easier to release the electron. Okay. And then ease of cation formation increase. Okay, so semakin mudah untuk release the electron. So this is true. 1, 2, 3. Okay, right. So the answer is D. Okay, right. Next, question 7. Okay, the size of magnesium, is less than, size of sodium less than magnesium 2 plus and less than Al3 plus. Which of the following explains this trend? Okay, effective nuclear charge increases. Okay, so this is true. Okay, betul, because proton number increase, jadi effective nuclear charge increases. Then the number of electron is the same, but the proton increases. Okay, so true. Okay, there are 10 proton only, and then the number of electrons and proton increases. Okay, so this is wrong. Okay, so 1 and 2. Okay, right. So 1 and 2, B. B. Alright, so 1 and 2. Okay, so this is correct. This is correct. This is wrong. Okay, right. Next, the graph shows all successive ionization energies of element P. Right, so if we count the total number of electron removed from this graph, 1, 2, 3, 4, 5, 6. Okay, so the 7th electron, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so it has 16 electrons. 16 point meaning that dia ada 16 electrons. So 16 electron, if you write the electron configuration for 16 electron, it is 1s2, 2s2, 2p6, 3s2, 3p4. Okay, right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Alright, so altogether we have 16 electrons. Okay, so 16 electrons, it is in group 16. Okay, 6 valence electrons. So P is expected to form a basic oxide. So group 16 is acidic. Okay, group 16 is acidic. So this is wrong. P is found in the third period of periodic table. So third period, yes, this is correct. The electron configuration of P is 1s2, 2s2, 2p6, 3s2, 3p4. Yes, correct. Okay, so the answer is C. Okay, C, iaitu 2 and 3. Okay, so the next question number 9. Going across the first transition series. Okay, so this is a transition series. Okay, block D. The nuclear charge increases. Yes. Okay, nuclear charge increases. the screening effect increases. Yes. Okay, because the size across a transition, only for transition. Huh? Okay. And then the number of shell filled with electron increases. This is wrong. Okay. Right. The answer is 1 and 2 B. Okay. Right, so the last question, particle M with proton number X and charge positive 1 is isoelectronic with a particle N with a proton number of X plus 1. Hence, it can be concluded that, okay, so kalau dia isoelectronic meaning that dia akan release one electron, okay, right. So, M has greater atomic radius than N. Okay, so betul lah. Okay, because um, because the size dia lebih banyak dia punya electron remove meaning that dia punya lebih banyak electron. Okay, M and N similar number of neutron. No. M and N has similar relative atomic mass. No. Okay, right. So the answer is one only. Okay, so it is A. Alright, so that's all for question number 6 to 10 for periodic table.